Hi, my name is Andy Osler. I'm a student here in electrical engineering at the University of Utah. And today we're going to talk about solar power and how it's useful and why we want to use it. The reason why we choose to use solar energy is because it's free. We receive solar energy from the sun every day, all the time. What we want to do with that solar energy that we get in the form of light and heat is turn it into something else that we can use. What we want is electrical energy. Electrical energy is what powers our lights, our computers, our air conditioners, everything that we have that's electronic. But what we need in order to do this is something that can actually convert that energy into electrical energy. And that's what we use is solar panels. Solar panels, as you can see, are made out of silicon and other materials that allow the solar panel to collect the energy and turn it into electrical energy. The electrical energy, the way that this electrical energy is formed is when the light from the sun hits the solar panel. It causes electrons inside of the solar panel to move and create an electrical current. And this electrical current will run our different devices that we have. But the problem that we see with this is in order to create more electrical energy to harness more electrical energy from the sun, we need a larger solar panel. And this makes solar energy a more expensive form of energy generation, but also it is very clean. So now that we understand what solar power and solar energy is and how it's created, we want to know what power actually is. Power is defined as the rate at which we're using energy. And this is important to us because in our experiment, we want to find out how much power and energy our solar panel is creating. So now that we know what power is, we need a way to calculate it. And the equation for calculating power is the voltage times the current that's going into our system. So what we're going to do is we're going to go out and calculate the voltage that's on our solar car first, and then we'll calculate the current. So now that we know what power is in forms of electricity, that it's the voltage times the current, what we need to do is find the voltage and the current that are coming off of our solar panel. So what we're going to do first is we're going to measure the voltage by hooking up our multimeter to this solar panel. And as we can see, that the multimeter is reading about 0.5 volts. In order to calculate the current, in our circumstances, it's a little bit difficult to calculate it individually. So what we were going to do is just calculate the resistance that we have and use Ohm's law to find it. So what we'll do is hook our multimeter up to the motor, which is the resistance that we have. And it's going back and forth between about 4 and 6 ohms, so it's about 0.5 ohms that we're getting out. So now that we have a resistance and a voltage, we can calculate the power that our solar panel is outputting when it's in the sun.
In order to calculate power, we know power equals to voltage times current. We measure the voltage to be 0.5 volts and resistance to be approximate 0.5 ohms. Therefore, from Ohm's law, current equals to voltage over resistance, which is 1 amp in this case. Equating back the two values for the voltage and current in the power equation, we get power equals to 0.5 times 1 amp, which gives us approximately 0.5 watts. As calculated previously, we could only get 0.5 watt out of the solar panel. Therefore, looking at this table, you could imagine how many or how much bigger solar panel we need to power up any of these appliances. This is the primary reason why solar energy is not readily used because of their inefficiency and high cost of production.
So now what we want to find is the efficiency of our solar car. The efficiency is important because it tells us the amount of energy that's being used of the energy that we're putting into the car. So the way that we find this is by finding the power out over the power that we're putting in. and this is a percentage. The way that we can find the power out is by finding the amount of work that's being done on our car over the period of time that we're using it. And the way that we calculate our work is by finding the change in kinetic energy of the car. And we know that our car has kinetic energy because it's moving, it has a velocity. So how we'll do this is find the change in velocity of our car over the period of time that we're using it. So in order to calculate the power that's coming out of our solar car, what we need to do is calculate the kinetic energy, which is equal to 1/2 mass times the velocity squared. So what we're going to do is measure how fast this is going using a radar gun. So I'm just going to set it down over here in the sun. And as you can see, velocity is equal to about 3 kilometers per hour.
In order to calculate efficiency, we know that efficiency is power out over power in times 100. We already calculated our power in to be 0.5 watt, and power out is just the kinetic energy generated by the car while in motion. The mass of the car is roughly 0.14 kilograms, and the velocity is 0.834 meters per second. Therefore, power out equals to half times the mass times the square of the velocity, which yields us 0.049 watt. Equating back the power out in the main efficiency equation, we get efficiency equals to 10%. That signifies the point why solar energy, being free and the cleanest source of energy in the world, is not used as the primary source of energy.
So now that we've learned about solar power and energy and the efficiency of solar power, we can see that it's not the most efficient way to generate energy. This is why it's so expensive and it's not widely used in the world. But there are people that are out there trying to develop new ways to make it better, make it more efficient, and make it more available to people in the world. Hope you guys had fun learning about solar power and about energy. If you guys want to learn any more, you can go to the website www.ece.utah.edu.